Okay, time travel. Just the thought of it makes my mind wander. You ask people about it and you get all sorts of responses. Some roll their eyes, think it's pure movie magic. Mom. Others get this dreamy look, imagining all the possibilities. I probably lean towards the dreamy side, but with a healthy dose of, yeah, right, mixed in. But this article, it makes you think, doesn't it? It suggests that maybe, just maybe, it's not as far-fetched as we think. It starts by talking about how we normally see time and space as these fixed, absolute things. A minute is always 60 seconds, right? 5 meters is always 5 meters. That's just how it is, or is it? That's where Einstein comes in with his theory of relativity. It's like he took our nice, neat little box of understanding and just shook it all up. This theory, from way back in 1905, basically says that the laws of physics apply everywhere, no matter how fast you're going or how strong the gravity is. And the really mind-blowing part, time and space aren't these absolute things we thought they were. They're relative. Relative. What does that even really mean? Well, as I understand it, it means that how you experience time and space depends on how you're moving. Imagine that your very motion can change how you perceive something as fundamental as time. The theory suggests that if you're moving really, really fast, time would actually appear to slow down for you compared to someone who's standing still. But to you, everything would feel normal. It's like your own personal timeline gets a little stretched out. And the same kind of thing happens with distances, apparently. This whole idea is called time dilation, and it's a direct result of this relativistic motion. And get this, Einstein also figured out that gravity plays a role too, that it can actually mess with space and time itself. Time dilation, it sounds like something straight out of a science fiction movie, right? Like some plot device to get our heroes into the future. But the article says it's actually happening all the time, just on a scale we don't normally notice. Think about it, if we could travel close to the speed of light, our time would slow down so much relative to someone on Earth. We could go on this incredible journey, and when we came back, the people we left behind would have aged way more than we did. It's almost like a real-life time skip. And here's where it gets really interesting. The article brings up these tiny particles called muons. They're created way up in the Earth's atmosphere by cosmic rays, and they travel at almost the speed of light. Now, these muons are actually pretty unstable and don't last very long when they're just sitting still. But because they're moving so incredibly fast, time dilation kicks in, and they actually live much longer than they normally would. This extra lifespan allows them to travel all the way down to the Earth's surface, which they wouldn't be able to do otherwise. And this isn't just some theoretical idea. Scientists have actually measured this, confirming that time dilation is a real thing. So, in a way, these high-speed muons are actually time traveling relative to us slower folks on the ground. That's a real aha moment for me. It's not just a theory, it's something we can observe. But it's not just about speed, is it? Gravity also gets in on the time-bending action. Einstein's general theory of relativity, which builds on his earlier work, says that really massive objects actually warp the fabric of space-time. And this warping has an effect on time, causing it to slow down near these massive objects. The stronger the gravity, the slower time seems to tick. It's like gravity is a time tamperer. The article even mentions that clocks closer to sea level actually tick ever so slightly slower than clocks at higher altitudes because the gravity is a bit stronger closer to the Earth's center. The difference is tiny, almost imperceptible, but it's there. And then there are black holes. Those things are just mind-boggling. They have so much mass packed into such a small space that their gravity is insane. The article says they can distort space-time to the point where time almost stops completely. Imagine that. If you could somehow survive a trip into a black hole, which, let's be honest, sounds terrifying, you could potentially emerge into what would feel like the blink of an eye for you, but an incredibly distant future for the rest of the universe. It's a chilling but utterly fascinating thought. Of course, actually hopping into a spaceship and traveling near the speed of light or taking a dip into a black hole to visit the future, that's not exactly something we can do right now. Our technology just isn't there yet, and the energy requirements would be astronomical. But the main point of the article, the thing that really sticks with me, is that time travel isn't just some crazy idea from a science fiction writer's imagination. It's already happening on a tiny scale with those muons zipping through the atmosphere. It's a testament to how strange and wonderful our universe really is, constantly surprising us with things that seem completely counterintuitive. It really makes you think about how we perceive time, how we measure it. It feels so constant, so reliable in our everyday lives. But When you start to look at it through the lens of relativity, you realize it's much more fluid, much more bendable than we ever imagined. It's a reminder that there's so much more to the universe than what we can see and experience directly. So yeah, maybe we're not going to be building time machines anytime soon, but the fact that time itself can be stretched and squeezed by speed and gravity, that's a form of time travel already happening. It adds this whole new dimension to how we understand existence, this gentle whisper that time isn't as rigid as we thought. And who knows what the future holds. As our understanding of physics grows and our technology advances, maybe those fanciful ideas won't seem so fanciful after all. For now, I'll just have to marvel at the fact that in the grand scheme of the cosmos and in the tiny world of subatomic particles, time is already moving in mysterious ways, perhaps offering us a subtle, continuous echo of time travel.